I'm Mike Clifford. I'm a land surveyor, so you know where I'm coming from. I deal with spatial information. I capture spatial information in very small places, house lots, construction sites. Surveyors are always looking at new technology. It's always changing. We always look to new technology for competitive advantage and also to have some fun. And that's what brought us to laser scanning. Time passes slowly, huh? Seconds is eternity. I should keep talking if I was smart, right? So laser scanning. If you don't know what laser scanning is, 3D laser scanning, you may know what LiDAR is. LiDAR uses laser to capture surface topography. Using about the size of a small, old-fashioned portable black and white TV on a tripod. It captures XYZ points. So the end result is a point cloud, which is a vector model for your GIS people. It's not raster, it's vector. And it has a lot of applications. 3D laser scan. No one start again. This is one of the devices we use to get an idea. LiDAR can happen from airplanes. FEMA uses it to map entire nations. We use it on the ground to map buildings, typically construction applications, documentation of things that are being changed and reworked or just preserved. My mental clock is going off. This is usually a 40-minute presentation from me, by the way. Just to get an idea of the stress that I'm under.
So get rid of the on-mouse click thing.
Yes.
There we go.
All right, this is coming up. So coming in tonight, I always like to look for a local project you might recognize. I actually worked on this building under construction. How cool would that have been to have a scanner? That was 20-something years ago. There was no windows, the wind was blowing. There was no scanner, so I looked up the street. Up the street, the Stata Center, don't trip on it if you walk by. There's a lot of crazy buildings, crazy design. Frank Carey is our patron saint of billable man hours. It was designed in 3D, laid out in construction in 3D. Seriously, there was cost savings with this. So in the end, we did surface topography. It was in 3D. I can elaborate now.
Oh, okay, hold on. So turn that off, turn that on. There we go. Now we're.
I gotta put a stack.
There you go.
It's the animation.
Hold on.
I'll talk about the Stata Center.
I'll say.
With the Stata Center was that there was no column line grid. We had to make up a 30 by 30 foot grid, really for the plumbers to use in the carpenters, just to make some sense out of it. But we used 3D towards the end of the project to map the facade. There was an issue that, a typical construction issue, to get the steel skin to fit on top of the steel framework to account for the, I wasn't even prepared to talk in this. Should I just hit the arrow? Or enter, can you enter? That's the arrow. All right, another application, you're gonna have to time me. The Central Artery had a lot of, the worst smart people on the Central Artery, very smart people. They realized that nobody would want to look at this thing at 500 Atlantic Gap done by some station when it was done. So they had embedded into the structure steel plates, knowing that somebody may want to wrap something around that. And right now there is a hotel wrapped around it. We use scanning to capture that data. They wouldn't put up scaffolding for us. We had to safely capture the data. So we modeled the steel structure that was used to design a hotel building. I think that's better looking than the hotel. But this is a campus high school on Morrissey Boulevard. We were hired to lay out the building in construction, and the contractor said, wait a minute, is this building gonna fit? There's existing buildings, this new building's going inside. We went there on a Saturday, there was no kids there, had the place to ourselves. We modeled the site, the buildings, to make sure everything fits, nothing's in the way, nothing's bumping. This here's the column grid, conventional column grid that allowed us to model the new building and design to make sure it fit. This is, boy, I've got to show you this. This is not beautiful, but this is what I call 20th century surveying. My field crews are doing this, they did this today. A bunch of points, X, Y, Z, point number, northern, eastern elevation, all zero. A little description of what it is. And then the sketch here where the field chief is trying to make sense of this for the drafter, for the designer, for the architect, with those little abbreviations, as chicken scratches and so forth. 20th century surveying, most surveying is done that way. This is 21st century surveying. This is an intersection in Dorchester. We were asked to model it. It's a crazy intersection like we just saw. A lot of traffic, a lot of people. So we scanned this from the ground, not the air, from the ground, using 3D laser scan. This looks like a plan view. This is really taken from the ground. It's simply the edges of the buildings model. This is Uptown. This is Beacon Hill. Very similar effort. And I'll just stop and point out that when we do scanning, it's just the facts. We're surveyors. Aesthetics doesn't come into it. But there are some kind of cool noirish images we captured. This is very quickly an accident scene, some forensics. Poor fellow was electrocuted working on that building. Some flashing he was working on. He survived, but hurt seriously. He came into contact with an electric line which was too close. Why was it too close? Who can tell me? Why was the wire too close? The post tilted. When we were sent out to do the survey, nobody told us that. I didn't tell my field crew that. I was looking at the scan with the forensic engineer, and we looked at the same time and said, hey, wait a minute, there's the liability, that post tilted. That's why those things are so close. And you don't want to scan here. Our LiDAR picks up whatever it sees first. Top of grass, top of shrubs don't mean a whole lot. Water doesn't mean much. So scanning likes urban areas, likes hard surfaces. And this is a building in Milford, Mass. If you go to see it, you may have trouble finding it. The city was going to knock this down. Our client is a contractor that specializes in historic restoration. We're also in the same city. They decided to move this about a mile up the hill, stone by stone. So to do that, they needed a map. So they can number the stones, that's the cloud, 3 dimensions. They wanted this done in 3 dimensions for geographic correctness, geometric correctness. And I heard a buzzer, so we produced a set of CAD files so they can number the stones and take the thing apart, put it back the way they found it. So that's laser scanning. I'll end with a prediction. In 5 years, when the software that people use catches up with our ability to capture this data, we're going to see things change. The way things, are done will be starting to change. So if you can find my email address, it will show up somewhere on the internet. Send me a line, and I could maybe send you a small point card to play with. And that's it.